Hello, I'm Welder Oliveira. I'm a math and statistics teacher, and today I'm here to teach you how to derivate this expression here. My classes are doing by using this tool here, this whiteboard. In this whiteboard, we can interact by voice, by written. You can written with me as well here, and we can discuss. I will do you a lot of questions in order to evaluate your your doubts, and I will just give you a show here in how this works. So let's compute the derivative of this function. Well, in order to compute this derivative, first I need to write here a note. First, note that for any real number a, I can write a as the exponential of the logarithm of a. That's because the exponential and the logarithm are inverse functions of each other, so it can cancel out. So x to the x can be written as exponential of logarithm of x, and this can be rewritten as the exponential. I can bring this x here to the front here using a property of logarithm. What is in the exponent, I can bring it down here in the front of the logarithm, so that will be the exponential of x times ln of x. That being said, so the derivative of x is the derivative of this function, which is the derivative of this here, just making the substitution. The derivative of the exponential. Let me just put another color here in order to highlight what I am about to say. So let me just return here. Okay, so let's do this derivative here. See, the outmost function is an exponential. The innermost function is this, which is in red, is a product between x and logarithm of x. So we can apply the change rule. So here we can apply the chain rule. The chain rule tells us to derivate the outmost function, which in this case is the exponential. So we have the exponential of x, ln of x, okay, times, now we can put here the derivative of this product is this times the derivative of this product, that by the change rule you derivate the outmost function, which is itself, the derivative of the exponential is itself, and multiply that by the derivative of the innermost function, which is the derivative of this product here. Let's compute this derivative of this product. We have x times ln of x is equals to, as this is a product, we can apply the product rule, which tells us that the derivative of a product is the derivative of the first times the second plus the first times the derivative of the second. Let's just do the computation. Derivative of x is 1 times ln of x plus x. Derivative of ln of x is 1 over x. Let's return to black. This here is just ln of x. This here cancels out with this one. This here will be just 1. So ln of x times 1. So f of x derivative, the derivative of f of x will be, let's continue from here, will be exponential of x ln of x times this ln of x plus 1. Final answer? No, quite not, because we can return this expression here to the original form, because that will be a more nice answer, because the function is x to the x power. It's a good idea to provide the result as x to the x power again. So the derivative of x, the f of x, is this here. I will return to x to the x power times, I will put 1 first in order to not get any confusion with this x and this 1 doing inside the ln. So this is 1 plus ln of x. So here, final answer. The derivative of x, x to the x power, is x to the x power again times this part here, 1 plus ln of x. Quite interesting. So this is just a show to you how my classes works. I give you here an example. We compute together a derivative. We can study in our classes of calculus limits, derivatives, integrals, whichever topic you want to study in calculus. I hope we can get in contact and you can study together all of these stuffs. I'll see you next time. Bye bye.